Alright, this is exam review number 1, and I wanted to work out the problems for you so that you could go back and look at the problems at your own pace. I also want to set the clock for myself so I don't run over my time for YouTube. So I'm going to go ahead and start that. I'll kind of pull that out of the way. Limits. The first topic that we're going to review is limits. I want to remind you that a limit is simply a y value that is being approached as you approach a particular x value. And when we did these, we looked at them graphically, we looked at them analytically, and we looked at several strategies to solve or to find a limit. In letter A, or in any of these, the first thing you want to try to do is direct substitution. Hopefully you'll be able to just simply substitute the number, find the output. But if there's a discontinuity, then we have a problem, and then we have some strategies that we can use to find the limit. So in letter A, if I substitute 3 in the numerator, 3 squared is 9, and 9 minus 9 is 0. So the first thing that I see is that in the numerator I get 0. Now that's okay as long as I don't get 0 in the denominator. In the denominator, if I square 3, I get 9, and 9 minus 15 is negative 6, and negative 6 plus 6 is 0. That's a bad thing because, as we know, division by 0 is undefined. So that strategy did not work. So I'm going to look at a strategy of trying to reduce or factor the numerator and the denominator and reduce. So if I factor the numerator, I'll get x plus 3 times x minus 3. In the denominator, when I factor, I'll get x, 3, 2, minus, and the x minus 3's divide out. So literally what I've now done is I have removed my discontinuity. Now, after removing the discontinuity, I can substitute the 3 in the numerator and the denominator factor that's left over. So in the numerator, 3 plus 3 is 6. In the denominator, 3 minus 2 is 1. 6 divided by 1 is 6. So the y value, if we were to actually look at that graph, the y value that we would be approaching is a y value of 6, and that would be the limit from the right and from the left. Letter B is a limit that we memorized. This is the same thing as finding the limit as x approaches 0. We can pull the 5/3 out front, and that would be x over sine of x. Now the limit as x approaches 0 of the 5/3 is simply 5/3. The limit as x approaches 0 of this function is a special limit that we memorized whose limit is 1, so the outcome is 5/3. Again, that's just a special limit that we memorized. We looked at the graph to see what that limit would do. Letter C, notice that we're approaching positive infinity, which means that the key to this problem when you're approaching positive or negative infinity is end behavior. So all we're really trying to figure out, it's like a pre-cal idea, what's the function doing at the ends? Now, to do that, we're going to look at the highest power term in the numerator and the highest power term in the denominator. And what you notice there is the degree in the numerator and the degree in the denominator are the same. So this is all about the horizontal asymptote. In this case, the horizontal asymptote would be the quotient of the leading coefficients in the numerator and denominator. The leading coefficient in the numerator is negative 1, and the leading coefficient in the denominator is 2. So if we were to graph that function, as we go towards positive infinity, the function would be approaching a horizontal asymptote of negative 1/2. Letter D is the same scenario. Again, we're approaching positive infinity. So we're going to look at the degree in the numerator, which is 3. We're going to look at the leading coefficient in the denominator. The degree in the numerator is 3. The degree in the denominator is 1. So this would be a function that some people would consider or call top-heavy. So in this case, there is no horizontal asymptote. There is a slant asymptote. We don't have to find it. But since there's a slant asymptote, we know that the function is either approaching positive infinity or negative infinity at the end. Either way, if we're approaching positive infinity or negative infinity, the limit does not exist because of unbounded behavior. Letter E, same thing. Again, we're talking about in behavior in letter E because we're approaching positive infinity. The degree in the numerator is 1. The degree in the denominator is 4. So this would be considered bottom heavy. Some people refer to it as being bottom heavy. But in other words, the degree in the denominator is greater than the degree in the numerator. And in that case, the horizontal asymptote is 0. So as we go towards positive infinity, if we were to graph this thing, the y value that we would be looking at is 0. Letter F is a special limit, and hopefully you recognize letter F to be the limit as h approaches 0 of f of c plus h, where c is a particular value, minus f of c over h. In other words, this is the definition of derivative, and this is a concept that you'll want to go back either in your notes or in your note cards and make sure you know the various forms of the definition of derivative. But when you see this scenario, you're to look and recognize all they're really trying to get me to do here is to find the derivative. Now the question is, what am I trying to find the derivative of? Well, my function is here. I'm trying to find the derivative of sine of x. So the function f of x is sine x, and I'm trying to evaluate the derivative of that function at pi over 6. So if I find the derivative of sine x, I get cosine x, and if I evaluate cosine x at pi over 6, which remember is 30 degrees, the cosine of 30 degrees is root 3 over 2. So again, that one is a special limit. It's asking me to find the derivative, but it's kind of a sneaky way. They're expecting me to remember that that's the definition of the derivative. Letter G, I can see again that if I try to substitute 2, there will be a discontinuity. So I'm going to try to factor and remove the discontinuity. In the numerator, I'll get x 4, 2. I want a positive 2. And you can see that the discontinuity or the factor will remove. So I've now removed the discontinuity. I can substitute the 2 in the remaining factor in the numerator, and 2 plus 4 is 6. So if we were to graph that function, there would be a hole in the graph at 2, but from both sides, the left and right limit would be approaching a y value of 0. Finally, in letter H, if I try to substitute a in place of x, of course I'll get 0 in the denominator. I'm going to clear the board so I can have a little bit of space here. Once I see those radicals, one of the strategies that we use is to either rationalize the numerator or rationalize the denominator. So I'm going to multiply by the conjugate, which would be the square root of x plus the square root of a. And I'm going to do the same thing in the numerator and denominator. So really I'm multiplying by a value of 1. When I multiply that out, I'm going to bring that down here. I'll get the limit as x approaches a. So in the numerator, I'll get square root of x times square root of x is x. The square root of a times the square root of a is a, and that'll be minus a. Now hopefully you can see that the middle term, the negative square root of a times square root of x, positive square root of a times square root of x would cancel out. And so I'll end up with x minus a in the numerator. Now in the denominator, do not distribute, or as you all like to FOIL, do not distribute those two factors together, because what we're hoping to do is to remove a factor and to remove a discontinuity. You can see that the x minus a in the numerator will divide out with the x minus a in the denominator. So now I can use direct substitution since I've removed the discontinuity and get 1 over square root of a plus square root of a, which is equal 1 over 2 square root of a. If you need more work on limits, go back to your notes, go back to the very first packet of the year, and take some time to look at those. But these are the basics of limits. Again, it's a y value that we're approaching. We're going to try direct substitution when we're approaching a particular value, like an A, B. F is a special one because it's the definition of derivative. You want to spend some time with that. When we're approaching infinity or negative infinity, the key idea there is to consider the end behavior and the horizontal asymptotes, or if there is a horizontal asymptote. Don't get caught up on limits. They're really not that hard. Just use these strategies and you will be okay. All right, so this is the first video review for the exam, and I'm going to post other videos for the other problems.